Welcome to the next edition of the HP Discover podcast series. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host and moderator for this ongoing discussion on IT innovation and how it's making an impact on people's lives. Our next big data case study discussion explores how large-scale monitoring of rainforest, biodiversity, and climate has been enabled and accelerated by cutting-edge big data capture, retrieval, and analysis. We'll learn how quantitative analysis and modeling are generating new insights into what's happening in tropical ecosystems worldwide, and we'll hear how such insights are leading to better ways to attain and verify sustainable development and preservation methods and techniques. To learn more about data science and how hosting that data science in the cloud is helping in the study of biodiversity, we're pleased to welcome our guests. We're here with Eric Figris. He's Senior Director of Technology of the Team Network at Conservation International in Arlington, Virginia. Welcome, Eric.
Hi, Dan. It's great to be here. Thank you.
We're glad to have you. We're also here with Jorge Humada. He's Executive Director of the Team Network, also at Conservation International. Welcome, Jorge.
Great to be here.
Let's start with the driving trends here. Clearly, knowing what's going on in environments in the tropics helps us understand what to do and what not to do. How has that changed? We spoke about a year ago, Eric. Are there any trends or driving influences that have made this data gathering more important than ever?
Well, what we're seeing over this last year is we've been able to roll out our analytics systems across the Team Network. And so we're having more and more uptake with our protected area managers using the systems. And we have some good examples of the results being used. For example, in Uganda, we noticed that a particular cat species was trending downwards, and the folks there were really curious why this was happening. First, they were excited that there was this cat species that was previously not known to be there. And in this particular forest, it's a gorilla reserve, and so one of the main drivers around the reserve is ecotourism's people paying to go see the gorillas. And so once they saw that these cats are going down, they started asking questions. Well, what could be impacting this? And our system told them that, and they realized that the way they were bringing in the ecotourists to see the gorillas had shifted, and that was potentially having an impact of where the cats were. They would only use a certain part of the protected area, and it allowed them to readjust and think about their practices to bring in the tourists to the gorillas.
Information at work.
Information at work at the protected area level, yeah.
Right, cool. Just to be clear for our audience, the Team Network stands for the Tropical Ecology Assessment and Monitoring. Jorge, tell us a little bit about how that came about, the Team Network, and what it encompasses worldwide.
Yeah, so the Team Network, it was a program that started about 12 years ago. And it started basically to fill a void in the information we have in tropical forests. Tropical forests cover a little bit less than 10% of the area, terrestrial area in the world, but they have more than 50% of the biodiversity. So they're the critical places to conserve from that point of view. And despite that fact, we didn't have any information about what is happening in these places, so that's how the Team Network was born. And the model was to use data collection methods that were standardized, that were replicated across a number of sites across the tropics in all 3 continents, and have systems that would store that data and analyze that data and make it useful. So that was the main motivation.
And so, of course, it's super important to be able to collect and retrieve and put that data into a place where it can be analyzed. It's also, of course, important to then be able to share that analysis. Eric, tell us what's been happening lately that has led to the ability for all of those parts of a data life cycle to really come to fruition.
Sure. So we let's see. Earlier this year, we completed our end-to-end system. So we're able to take the data from the field, from the camera traps, from the climate stations. We bring it into our central repository. We then push the data into Vertica, which is used for the analytics, and then we've developed a really nice kind of front-end dashboard type data viz that will kind of show the results of basically species populations in all the protected areas where we work. The analytical process also starts to identify what could be impacting the trends that we're seeing at a per species level. And this dashboard also lets the user look at the data in a lot of different ways. They can aggregate it, they can slice and dice it in different ways to look at different trends.
Jorge, what sort of technologies are they using for that slicing and dicing? Are you seeing certain tools like distributed R or visualization software and BI packages? What's the common thread, or is it vary greatly?
Well, it depends on the analysis, but we are really at the forefront of analytics in terms of big data. And as Michael Stonebreaker and other big data thinkers have said, the infrastructure, the big data analytics infrastructure, has concentrated on the storage of big data, but not so much on the analytics. And we break that mold because we're doing very, very sophisticated Bayesian analytics with this data. One of the problems of working with camera trap data is that you have to separate the detection process from the actual trend that you're seeing, because you do have a detection process that has error. So we do that with hierarchical models, and it's a fairly complicated model. And just using that kind of model, but in a normal computer will take days and months. And with the power of Vertica and parallel processing, we've been able to shrink that to a few hours. We can run all our 500 or 600 species, 13 sites all over the world in 5 hours. So it's a really good way to use parallel processing. We've been also more recently working with distributed R, a new package that was written by HP folks at Vertica, to analyze satellite images, because we're also interested in what's happening at these sites in terms of forest loss. So satellite images are really complicated because you have pixels, millions of pixels, and you don't really know what each pixel is. Is it forest? Is it an agricultural land? Is it a house? So with random forest trees, which are these analytical techniques, fairly sophisticated ones, we can tease that out. But running that on normal R, it's kind of a problem. And so distributed R is a package that actually takes some of those functions like random forest and regression trees and takes full power of the vertical, the vertical processing of Vertica. So we've seen tenfold increase in performance with that, and it allows us to get much more information out of those images.
And not only are you on the cutting edge for the analytics, you've also moved to the bleeding edge on infrastructure and distribution mechanisms. Tell us, Eric, a little bit about your use of cloud and hybrid cloud.
So yeah, to back up a little bit, I mean, we ended up building a system that uses Vertica. It's an on-premise solution, and that's what we're using in the team network. We've then since realized that, hey, the solution we built for the team network can also be readily scalable to other organizations and government agencies, et cetera, different people that want to manage camera trap data. They want to do the analytics. And so now we're at a process where we've been essentially doing software development and producing software that's scalable, so that if an organization wants to replicate what we're doing, we have a solution that we can spin up in the cloud that has all the data management, the analytics, the data transformations and processing, the collection, all the data quality control. It's all built into a software instance that can be spun up in the cloud.
And when you say in the cloud, are you talking about a specific public cloud in a specific country, or all the above, some of the above?
So yeah, I think that the answer is all the above. Certainly it will work within the HP cloud. We'll be using Vertica, or we are using Vertica on demand. We're actually going to transition our existing on-premise solution into Vertica on demand. And the solution we're developing uses all mostly open source software. And it can be replicated in the Amazon cloud or other clouds that have the right environments that we can get things up and running.
Jorge, how important is that to have that global choice for cloud deployment and attract users and also keep your costs limited?
It's really key, because in many of these countries, it's very difficult for some of these governments to span out their own solutions on the ground, and cloud solutions offer a very good way, effective way to manage data. And as Eric was saying, the the big limitation here is what cloud solutions are available in the country. And right now, we have something with cloud on demand here, but in some of the countries we might not have that same infrastructure, so we have to contract out different vendors or whatever. But it is, I think it's a way to keep costs down. It is a way to deliver the information real quick, and it's a way to store the data in a way that is safe and and secure.
Eric, now that we've got this ability to retrieve, gather, analyze, and now distribute, what comes next in terms of having these organizations work together, and do we have any indicators of what the results might be in the field? How can we measure the effectiveness at the end point, that is to say, in these environments, based on what you've been able to accomplish technically?
Yeah, that's a good question. So one of the nice things about the software that we've built that can run in the various cloud environments is that it can also be connected. So that as we say, for example, if we start putting these solutions in a particular continent and there's countries that are doing this next to each other, they're not going to be silos. That we'll be able to share an aggregated level of data across each other so that we can get a kind of a holistic picture of what's happening. And so that was very important when we started going down this process, because one of the big inhibitors for kind of growth within the environmental sciences is that there are these traditional silos of data that people and organizations keep and sit on, and that they essentially don't share. And so that was a very important driver for us as we were going down this path, building the software.
Jorge, what comes next in terms of technology? Are the scale issues something you need to hurdle to get across? Is there analytics issues? What's the next requirements phase that you'd like to work through technically to make this even more impactful?
Well, I think as we scale up in size and we start having more granularity in the countries where we work, the challenge is going to be keeping these systems responsive and the information coming. And I think right now one of the big limitations is the analytics. I mean, we do have analytics running at top speeds, but once we start talking about countries, we're going to have on the order of many more species and many more protected areas to monitor. And so I think this is something that the industry is starting to move forward in terms of incorporating more of the power of the hardware into the analytics, rather than just the storage and the management of the data. And we're looking forward to keep working with our technology partners, in particular HP, to help them guide this process. And as a case study, we're very well positioned for that because we already have that challenge.
It also occurs to me that you are a harbinger, a bellwether for the Internet of Things. Much of your data is coming from monitoring sensors, devices, cameras. It's in the form of images, raw data. Any thoughts about what others who are thinking about the impact of the Internet of Things should consider, now that you've, in a sense, been there?
Yeah, I think one of the limitations, and when we talk about big data, is we're talking about data collected from phones and from cars and from human devices. Humans are delivering the data. But here we have a different problem. We are talking about nature is delivering the data, and we don't have that infrastructure in places like Uganda or Zimbabwe or Brazil. So we have to start by building that infrastructure, and we have the camera traps are an example of that. But we need to be able to deploy much more, much larger scale infrastructure to collect data, diversify the sensors that we currently have, so that we can gather sound data, image data, temperature and environmental data in a much larger scale. Satellites can only take us some part of the way, because we're always going to have problems with resolution. So it's really deployment on the ground, which is going to be a big limitation, and I think it's a big field that is developing now.
Drones?
Drones, for example, have the capacity, especially small drones that are starting to be intelligent, to go and collect a lot of information and autonomously. And this is at the bleeding edge right now of technological development. So we're excited about it.
Well, great. I'm afraid we'll have to leave it there. We've been learning and exploring how large-scale monitoring of rainforest biodiversity and climate has been enabled and accelerated by cutting-edge big data capture, retrieval, and analysis. And we've seen how quantitative analysis and modeling are generating new insights into what's happening in tropical ecosystems worldwide. So a big thanks to our guests. We've been here with Eric Figris, Senior Director of Technology of the Team Network at Conservation International. Thank you, Eric.
Thank you, Dan.
And we've been joined also by Jorge Ahumada, the Executive Director of the Team Network, also at Conservation International. Thanks so much.
Thank you.
And a big thank you to our audience as well for joining us for this Big Data Innovation case study discussion. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host for this ongoing series of HP-sponsored discussions. Thanks again for listening, and come back next time.